In the previous video, we found minors and cofactors for all the elements of this determinant. We found M11, M21, M31, M12, M22, M32, M13, M23, and M33. We evaluated these 2 by 2 matrices, we found these values, and we also saw that cofactors are just signed minors. If you multiply the values of these minors with these signs, corresponding products will give us the cofactors. We'll have these 9 cofactors. We can see that these 4 are multiplied with a negative sign, which means the values of these 4 will flip. Minus 46 becomes 46, minus 4 becomes 4, minus 22 becomes 22, and 13 becomes minus 13. So these are the minors and cofactors for this determinant. Let's move on. Let's also find the magnitude of this determinant. We can do this using the first row. So if we do this, we have 2 times 0 times minus 7 minus 5 times 4. That's actually the cofactor corresponding to this element. So that's 2 times determinant of 0, 4, 5, minus 7. That's the cofactor for this element. That's actually A11. Then we have minus 3 times 6, 4, 1, minus 7. So this is the minor, and if we take the minus sign into account, then together these two form the cofactor. Then we have 5 times 6, 0, 1, 5. That's the cofactor for this element. So we can rewrite this. We can say this is equal to 2 times A11 plus minus 3 times A12 plus 5 times A13. And we can even generalize this. 2, minus 3, and 5 are the elements A11, A12, and A13. So we can rewrite this as this is A11, A11, small stands for the element and capital stands for the cofactor, plus A12, A12, plus A13, A13. Now this is the neat formula for the determinant. We take all the elements of this row and multiply them with their corresponding cofactors, and whatever the sum is, that's going to be a determinant. We can also expand this using the second row. Then we'll have A21, A21, plus A22, A22, plus A23, A23. All the elements of the second row multiplied by their corresponding cofactors. We add them and we get the determinant. We can even do this column wise. We can take this second column. We'll get A12, A12, plus A22, A22, plus A32, A32. Again, all the elements of this column multiplied by their corresponding cofactors. We add them, we get the determinant. But there's also something that I like to call faulty wiring. If we don't multiply with their corresponding cofactors, if we take the cofactors from a different row, we get something else. If we pair with cofactors of a different row, let's see what we get. If we pair A11, A12, and A13, the elements of the first row with the cofactors of the second row, let's see what we get. Pause the video. If you want to try this out, you'll be surprised with the answer. Okay, let's do this together. A11 times A21 plus A12 times A22 plus A13 times A23. Elements from the first row, cofactors on the second row. So this is 2, this is 4, A21 is 4, this is minus 3, this is minus 19, A13 is 5, A23 is minus 13. So let's multiply. 2 times 4 is 8, 3 times 19 is 57, minus minus plus, so it stays 57. 5 times minus 13, that's minus 65. Now let's add them. So 8 plus 57 plus minus 65. 8 and 57 add up to 65. Minus 65 gives 0. And I was also surprised. If we pair them in this order, if we take elements from one row and cofactors from a different row, we always get a 0. And we're not going through the proof in this video. We'll get some intuition by verifying it for some generic 3 by 3. Let's take this determinant A, B, C, D, E, F, G, H, I, and let's do some faulty wiring with these variables. We have A11 times A21, first element of first row, but cofactor from the second row. Similarly, A12, A22, and A13, A23. So we're going to add these three. Let's find A21. That's going to be Bi minus Ch, that's the minor. And what's the sign? Plus minus, the sign is negative. So A21, that's minus Bi minus Ch. So this becomes Ch minus Bi. Let's find A22. That's going to be AI minus GC or CG. It stays positive. This sign is plus. So A22 is AI minus CG. Then we have A23. For this element, we have AH minus BG. That's the minor with a negative sign because plus minus plus, minus plus minus. So A33, that's going to be the negative of that. That's BG minus AH. Now let's multiply them with the elements and see what we get. A11 is A, so that's A times CH minus BI plus B times AI minus CG plus C times BG minus AH. Let's expand this. We have ACH minus ABI plus BAI, that's also ABI. ABI and minus ABI are cancelling each other. Let's see, minus BCG plus BCG and minus ACH. So we have 6 terms. ABI minus ABI cancel each other. ACH and minus ACH also cancel each other. And BCG and minus BCG, they also cancel each other. So all in all, we get 0. All of these terms cancel each other out, which means that faulty wiring is in fact giving us a determinant equal to 0.